Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math Olympiad algebra problem, and here we have 5 to the power of n minus 4 to the power of n equals to 3 to the power of n, and we will solve this problem for the values of n. So the very first thing we are going to do is here first we divide both of the sides by 4 to the power of n, and we write in this way. This is 4 to the power of n. It is also divided by 4 to the power of n, and in the right hand side we also divide it by 4 to the power of n. And now you focus first in the in the left hand side, and we see that this term and this are gone, and here we obtain 5 to the power of n over 4 to the power of n. Here we get minus 1 equals to 3 to the power of n over 4 to the power of n. And now in the next step we will use here the nice exponential law here, and you know about this law. If we have a to the power of n over b to the power of n, we combine the exponents of these two terms and we write in this way: a over b and its whole power n. So now we use this nice exponential law on both of the sides, and we get the output in the left hand side will be 5 over 4 and its whole power n minus 1 equals to, here in the right hand side we have 3 over 4 and its whole power n. So in the next step we will just focus on both of the sides, and you see that here if we talked about this 5 and 4, so you know that 5 is greater than 4. So if 5 is greater than 4 and we divide here both of the sides by 4, then you get 5 over 4 is greater than 1. And we already know that, and after that if we take the exponent n on both of the sides, then you get furthermore in this way 5 over 4 and its whole power n is greater than, we know that the 1 and its power n equals to 1. So now here we use the nice fact about the increasing and decreasing function. So you know that if we have, I can just write here, if you have some value b to the power of n, if we talked about some b to the power of n, and here if our b is greater than 1, then we say that b to the power of n is increasing function, and similarly if we have some b to the power of n and our b is lesser than 1, then we say that b to the power of n is decreasing function. So this is the nice fact we will use here, and you see that our base is 5 over 4, and if our base is greater than 1, then we call this function is increasing function. So according to this fact, I can just mention here, so according to this fact we say that this function 5 over 4 and its whole power n is increasing function. Okay, so if this function is increasing function and we subtract 1 from an increasing function, then it will remains the increasing function. So here we say that 5 over 4 and its whole power n minus 1 is also increasing function. And now we move towards the right hand side, and in the right hand side you see here we have 3 over 4, and if we make the relation between 3 and 4 and you say that 3 is less than 4, and if we divide both sides by 4, then you obtain 3 over 4 is less than 1. And now when we take the power n on both of the sides, then you get 3 over 4 and its whole power n is less than 1. But here you see that according to this law or this fact, our base is less than 1, so this function is called the uh, decreasing function, because here our b is less than 1. Then we say that 3 over 4 and its whole power n is decreasing function. So now we just combine the or we draw visually increasing and decreasing function. So here you see that the graph of increasing function will be looks like in this form. So this is represents the increasing function, and the graph of decreasing function will be looks like in this way. So this is the decreasing function, and you know that, or you see here in the diagram, increasing function and decreasing function will be intersect on one point, this point. So this point be the solution of the given problem, or this point be the solution of this equation. So here you have n, the variable is n, so we just find this point, or we just find the value of n here. Okay, so now we find this point of intersection. So in order to find the point of intersection, we need to take this value of n by assumption. So this is the our question statement: 5 to the power of n minus 4 to the power of n equals to 3 to the power of n. So now we find the value of n by inspection. So first we choose n equals to 0. So when you choose n equals to 0, then this will becomes 5 to the power of 0 minus 4 to the power of 0 equals to 3 to the power of 0. And you know that 5 to the power of 0 will be 1 minus 1 equals to 1, and this is 0 equals to 1. And you see here 0 is not equals to 1, so it is not possible. And now we check our question statement at n equals to 1. So when you substitute n equals to 1, then you get 5 to the power of 1 minus 4 to the power of 1 equals to 3 to the power of 1. And you see that 5 minus 4 will be 1 equals to 3, and it is again not possible. So this is not possible case. And we move towards n equals to 2. So now we substitute n equals to 2 in the question statement, and you get 5 square minus 4 square equals to 3 square. And we know that 5 square is 25, 4 square is 16, and 3 square is 9. So 25 minus 16 is equals to 9, and it is equals to 9. So this is hold. So we say that n equals to 2 be the solution of the given question. So here we just say that this is the point of intersection, and this point of intersection will be n equals to 2. And this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.